What this episode reveals first is not Neil deGrasse Tyson or Matt O'Dowd. It reveals the audience StarTalk thinks it has, and for once that's flattering. This is a 56-minute conversation about quasars, gravitational lensing, Rubin Observatory data pipelines, and whether machine learning will turn graduate students into expensive decorative plants. In other words, the show assumes you can handle a scientific idea that does not love you back. It assumes you'll stay even when the object of desire is not a black hole glamour shot, but a nasty little problem in inference. That is a stronger compliment to the viewer than most science media offers. And the real claim here is bigger than the title. The episode asks whether quasars are just spectacular objects, or whether they're the place where astronomy becomes honest about itself, about how much of the universe is reconstructed indirectly from light delays, lensing artifacts, statistical templates, and instruments doing the seeing for us. On that level, the video is excellent. It doesn't merely say quasars are bright. It says quasars are a test case for modern scientific knowledge. When the object is too far away, too energetic, too early in cosmic history, what counts as understanding? The strongest part of the episode is the explanation of what a quasar actually is and why it outshines the galaxy around it. Not because it's flashy, but because Matt O'Dowd refuses the lazy version. He doesn't treat a quasar as a magic lighthouse. He keeps returning to the engine, gas falling into a supermassive black hole, friction in the accretion disk, gravitational energy being converted into radiation with absurd efficiency. That matters, because the video's rigor comes from treating brightness as bookkeeping rather than poetry. The object is powerful because the energy budget is powerful. That sounds obvious, but in popular science it's weirdly rare. I also like the way the episode handles the clicky question in the setup. Did the Milky Way used to be a quasar? Because it mostly refuses to overpromise. The answer isn't a clean yes, and the conversation is better for that. They use the question to talk about scale, mass, feeding rate, and why not every galaxy with a central black hole gets to wear the quasar crown. That's a subtle virtue of the episode. It uses a speculative hook, then spends its time narrowing the claim rather than inflating it. A lot of channels use the question mark as a smuggling device. Here it's more like a trap door into the real physics. Then the episode hits its best stretch, gravitational lensing. This is where the conversation stops being a tour of cool objects and becomes a lesson in scientific reasoning. The key move is not just gravity bends light. It's that lensing lets you see the same quasar multiple times at different effective moments because each light path has a different travel time. That's the beautiful part of the argument, and also the part StarTalk handles with unusual clarity. Suddenly the quasar is not just distant, it's temporally shredded. You are looking at one object through several cosmic detours and treating the delay itself as data. That's a genuinely thrilling explanation because it teaches the viewer what counts as evidence in astronomy. Not proximity, not direct access, but structured distortion. And the visual of the lensed quasar, those multiple points of light arranged around the lensing galaxy, is where the whole episode cashes its check. Not because the image is pretty, though it is, but because it gives the audience a rare thing. A scientific image that actually bears the weight of the explanation around it. Too often science television flashes a telescope image like a decorative receipt. Here the image is the argument. You can feel Neil lighting up because the object is finally doing philosophy in public. One source, many appearances, time delays, hidden mass, model fitting. It's astronomy as forensic reconstruction. My hesitation begins when the conversation pivots into AI, finding lensed quasars, and handling Rubin scale data. Not because the point is wrong. The point is mostly right. Rubin Observatory will drown humans in images, and machine learning will be part of the survival strategy. But the episode occasionally glides over a real epistemic tension. Pattern recognition is not explanation. Matt does raise this. Credit where it's due, especially around the danger of models seeing what their training set prepared them to see. That caveat saves the segment. Still, the conversation sometimes makes the pipeline sound cleaner than it is, as if the problem is simply scale. It isn't just scale. It's selection effects, labeling assumptions, false positives, and the fact that a classifier can become a very efficient machine for institutionalizing your prior expectations. But here's why I still think the episode wins that section. It doesn't reduce the anxiety to jobs. The transcript tees up the joke, will AI replace grad students? And then quietly turns the real issue into cognition. What do we lose when the drudgery disappears? That is the right question. Not because suffering is sacred. Nobody needs to romanticize hand-classifying galaxies like it's monastic labor. The issue is that grunt work is often where researchers acquire texture, error intuition, and a feel for what the data resists. If you automate the repetitive layer, you may also automate the apprenticeship. That's a much sharper argument than the usual panic about robots stealing careers, and it gives the episode a seriousness that most tech-inflected science chatter never reaches. The Rubin Observatory segment is where the show becomes quietly moving. Not because the phrase 10-year movie of the night sky is poetic, although it is, but because it reframes astronomy from treasure hunting to surveillance of change. That's the conceptual upgrade this episode keeps making. Don't think of the sky as a static wallpaper with occasional explosions. Think of it as a living archive of motion, transients, microlensing events, variability, and systems revealing themselves only through persistence. The strongest thing StarTalk does here is make big data feel less like a Silicon Valley slogan and more like a new sensory organ for science. There is one omission worth naming, precisely because the episode is so good at method. It spends a lot of time on what new tools can reveal, and much less on how the social organization of astronomy shapes what gets revealed at all. Who gets telescope time? Whose models become standard? How data curation choices lock in future discoveries? Those are not side issues once the conversation turns to automated pipelines and observatories generating impossible volumes of information. The strongest part of the argument is also its biggest vulnerability. This episode celebrates tools of thought, but tools live inside institutions, and institutions decide which questions become legible. Even the talk show looseness ends up serving the substance. Chuck Nice keeps the discussion from hardening into a seminar. Neil supplies the broad conceptual framing, and O'Dowd keeps puncturing every temptation to drift into mystical language. That balance matters. The episode never pretends the universe is comprehensible because it is emotionally satisfying. It argues the opposite, really, that the universe becomes more interesting the moment you accept that your access to it will be mediated by inference, mathematics, and a bunch of suspiciously overworked computers. There's a dry joke hidden in the middle of this video. Humanity finally builds machines capable of reading the sky at scale, and the reward is discovering that the sky is even more inconvenient than we thought. So my verdict is emphatically positive. This is one of those rare StarTalk episodes where the enthusiasm is earned by the intellectual architecture underneath it. The central conclusion, that quasars and lens quasars are not just spectacular objects, but laboratories for understanding how modern astronomy works, isn't perfectly complete, especially once AI enters the frame. But it is impressively supported, unusually honest about uncertainty, and generous to the viewer's intelligence. More importantly, it models a version of science communication that doesn't confuse wonder with simplification. It lets wonder emerge from method. And if that's the kind of argument you like, less space is awesome, more show me how the claim survives contact with evidence, stick around. Because those are the videos worth fighting about.